Hey guys, Mr. Jenkins here with your notes for 2-7. Hopefully everybody's having a good day so far. If not, hope it gets better. So anyways, here we go. So we're going to talk about absolute value functions in this lesson. Your learning target would be that you can understand the graph of an absolute value function and the equation of an absolute value function, and also kind of relate that to the stuff we've done in 2-6. So how various transformations will affect it. So without anything else, we'll go ahead and get to it. It says the output of the absolute value function returns a positive value of its input. In its simplest form, f of x equals the absolute value of x. Remember, the absolute value is the distance from 0 on the number line, so it's always positive. It can also be described as returning the blank of the input value from the y-axis. So that would be absolute value. That color's not going to work. I think that's what goes there. It's absolute value, but I'll double check on the notes. Okay, so like in other words, 1 goes to 1, -1 goes to 1, -5 goes to 5, and so on and so forth. The vertex of the parent function, f of x equals the absolute value of x, is 0, 0. Based on what we just said, that makes sense because the absolute value of 0 is 0. And then its axis of symmetry, which we haven't talked a lot about. We will more when we talk about parabolas, but that's basically the line that you can fold it on where one side of the graph would land on the other. Anyways, the axis of symmetry is the vertical line, x equals 0. All right, jumping into some examples. Example 1 says, write the function rule for the parent function as a piecewise function, which we skipped that part, but I'll kind of briefly explain what that means, and then fill out the table of values and graph the function. Label the vertex and the axis of symmetry. All right, so a piecewise function is basically, where a graph changes direction. So kind of looking at these down here, you can see it kind of almost looks like two different graphs, and here is how you would do it. Okay, so if it's a V like this, I'll go ahead and show you how it looks. That's how the parent function is going to look. Then from here to here, or when x is greater than or equal to 0, the function rule is just y equals x. So that should say y equals x. And then from when x is less than or equal to 0, we'll just say less than 0, it's y equals -x. So again, this part right here is, don't have much room, if x is greater than or equal to 0, and then this part right here is if x is less than 0. Okay, so anyways, as we can see, -2 goes to 2, -1 goes to 1, 0 goes to 0, 1 goes to 1, and 2 goes to 2. And just to show you how you can get that quickly in your graphing calculator, it would look like this. So anytime I want to graph a function, I'm going to go to y equals on my graphing calculator, and we want to just graph the rule, the absolute value of x. So absolute value is under math, and then you want to go to number, so arrow over, and then it's the first one, ABS. So absolute value of x arrow out just to make sure it reads correctly, and then I can look at the graph, and there you go. Okay, so that's kind of what we're basing all of the rest of our work on. That is the parent function, right? So do the next example. All right, so for the next example, we will check it on our graphing calculator because I would if I was doing this problem and we're on a test, but let's think about it without a graphing calculator first, okay? So let's think about it on the basis of like 2-6, okay? So let's think about the transformations, right? So this part right here would be like an f of x plus 2, because that's kind of in the grouping symbol. They're not parentheses, but you treat them like parentheses. And then this one would be like an f of x plus 3. Okay, so if you pretty well know what that means, right? This is an up 3. And then our other one is a left 2. Okay, so if I just think about the graph I see in there, shifted the way I said, left 2, up 3, which one is going to match with that? So it looks like probably D, right? So let's see where that vertex is. Looks like -2, +3, which is exactly what we're looking for. So just based on that, what I know from 2-6 and what I just went over in example 1, it's got to be D. Okay, and then just focusing on the other details, right? You can see that from there, it's got that +1 slope on the right side. It's got that -1 slope on the left side. Okay, and so I'm realizing that I forgot to do a small part of example 1, so pardon me for that. So it said label the vertex on the axis of symmetry, so that's the part I forgot. So let's do that. There's your vertex right there, 0, 0. And the axis of symmetry is here. The line that kind of cuts our graph in half. And that is x equals 0. So, looking at the one we just did, its vertex is obviously at -2, 3, and its axis of symmetry is the line x equals -2. Okay, notice that your axis of symmetry is x equals the x coordinate of your vertex. Okay, so I said I would show you that in the graphing calculator, so let me do that real quick and then we'll move on. All right, so we wanted to do, I'm just going to edit what I have here. So absolute value of x plus 2, so I'm adding +2 and then arrowing out and then +3 outside. I'm going to look at it, just verify that way, and we can see that it does match up with the graph of t. Okay, so moving on, I think we have a couple more examples. So building off of what we just did, this is the general form of an absolute value function. So a times the absolute value of x minus h plus k. And remember, if you're multiplying outside the parentheses, that is a stretch or a compression. So remember, when the absolute value of a is bigger than 1, it is a stretch. When you've got a fraction, so like if a were 1/2, it'd be a compression. And then your vertex is at h comma k. Okay, and you'll get used to seeing this later, so this is actually a really good preview lesson too. All right, so looking at example 3, it says what are the vertex and the axis of symmetry of the function g of x equals 3 times the quantity, times the absolute value of x minus 2 plus 4. And then how is it transformed from the parent function? All right, so based on what I see here, I don't care about the 3 if I'm just thinking about the vertex. All right, so just to answer this question, it's at h comma k, right? H comma k. So now the question is, what's h and what's k? So remember, this minus sign is built in, right? So based on this, we know h equals 2. And this tells me that k equals 4. So without really thinking too much about it, just knowing the standard form, I know that the vertex of this guy is at 2, comma 4. So I'm going to go ahead and graph that, 2, comma 4. I also know that, based on what we've said, that my axis of symmetry is the vertical line, x equals 2. All right, without graphing really anything, okay? And so then the last part is, what does the 3 do, right? So 3 is going to stretch it, okay? So if it were, remember, if this were just a positive 1, I would have a point here and a point here, right? But if I multiply that by 3, if I stretch it by 3, then it's not going to go here. It's going to go, here, times 3, right? So it would go right there at, what's that point? 3, comma 7, right? So not here, but up 3. Not up 1, but up 3, okay? Or the next one, we could go, if the base one would be over 2, up 2, but our stretch by 3 would be over 2, up 6. So up 3 and then up another 3, right? So instead of our slope being 1, our slope is 3, okay, because of that stretch. All right, so that kind of gives me the shape of my graph. Go ahead and finish by making it a continuous function. All right, so just to verify, let's look on our calculators and see if we did it correctly. Desmos would be a nice thing to use to check as well, okay? So going back out to y equals, just double checking my work. I'm gonna have to clear it, I think. Let's see if we can insert, actually. Second insert. Yeah, and then that'll let me put, I think, something in front there. So I'm gonna do the 3. And then there we go. So 3 times the absolute value of x minus 2. Change that to a minus sign. And then outside we have plus 4. All right, so we can see that, well, it looks similar. We might want to zoom out a little bit just so we can, sorry, I like window a little better. So let's go out, make the x, really we just need to change vertically. So let's make the y max like 25. Look at the graph again. All right, so that looks a little bit weird just because I didn't change my x's, so just make that look a little bit better. Let's do the same on the y max just for scale purposes. So there you go, you get that tall skinny thing. And then you can also look at individual points, right? You could check it this way too. If I go to second and graph, I can look at a table, right? So we thought that it was going to go through 2, 4, right? So I can look at my table and it does go through 2, 4. We also thought that it goes through 3, 7, right? You can see 3, 7, you can see 1, 7. So we can see that we did do this correctly. Okay, and then we have one more example. All right, it says, what are the vertex and the axis of symmetry of the function in the graph? Let's go ahead and do that. That's the easy part. So vertex is right there. That looks like -1, +1, 2, 3, 4. negative 1, 4. I'm going to write that over here since we were explicitly asked about it. All right, and then the axis of symmetry is going to be x equals negative 1. So we'll call that AOS for short. And then what is the equation of our absolute value function? So that's where it gets just a little bit tougher. But let's just think about the vertex. So we know h equals negative 1, k equals 4. All right, so that's a start. Let me let that pop up real quick. So just based on that information, we would know its absolute value of x minus negative 1, so plus 1. Hopefully that looks right when it pops up. There you go, x plus 1, and then plus 4. So we know we have that based on where the vertex is. All right, now the other part is this. So what would flip it upside down? So that would be a reflection across the, you can't really do a reflection across the, well, I don't want to say that, but anyways, we did a reflection across the x-axis here. So that would be, so a reflection across x-axis is, just review from the last lesson, negative times f of x, okay? So we have negative, and then notice that it's not a negative 1 slope, right? What is it? It's a negative, well, we went down 1, right 3, down 1, left 3. So it's negative 1/3 slope, right? So we also have a compression there of, again, instead of negative 1 slope, negative 1/3 slope. So our compression is 1/3, right? So all that put together gives me my final answer, and I will just finish by showing that in the graphing calculator. And that'll kind of conclude our notes for this one. Make my window look more normal before I do that. Give it just a second. Sorry about the waiting. Okay, just making my window go back to normal. And now I'm going to type in what I just put there, right? So I'm just going to delete everything I have, so clear it, and go negative 1/3. So I'm going to put that in parentheses. So parentheses, negative 1/3, close parentheses. That's my A, and then times the absolute value. So we got a math over 1. There's absolute value of x plus 1. Arrow out, and then plus 4, and then hopefully that looks correct. All right, so it looks pretty good, but again, if we want to check details, right? Let's look for if we have the actual points. If our actual points look good, right? So we know it goes through negative 1, 4, so we'll double check that. Let's remember it also goes through 2, looks like 3. And then it also goes through negative 4, 3. So let's see when we look at our table if that all matches up. So negative 1 goes to 4, 2 goes to 3. Let's see. I'm going to hit second graph. So negative 1 goes to 4, that looks good. And 2 goes to 3. At that point, we can feel pretty good about the fact that we got this correct. Okay, so this is very good practice and reinforcement of 2-6. I know some of you guys had trouble with that. Hopefully this helps you further your understanding. But, you know, I'm here to help, so ask questions if you have any. That concludes our lesson for this section.